Everybody's Tyler here at the 2022 IRI, checking in with team number 4926 GalacTech. This team was the winners of the Indiana State Championship, as well as our host team here at IRI. So we're delighted to have them here in Columbus, Indiana. And talk more about this incredible machine, by the way, we have Asher, Rishi, and Isaac. 4926 GalacTech really kind of coming out of the woodworks this year, taking the Indiana State Championship. You didn't watch 4 fantastic matches in finals. You really got to go back and watch those as they took that championship. But we're going to cover their robot here. A great looking machine, great compact and awesome packaging as we go through on this. Of course, covering their intake all the way through their shooter and climber coming up here on Behind the Bumpers. This video on First Updates Now is made possible by viewers like you and also the following sponsors. If you're a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. Discover MSOE, where hands-on learning today can lead to real-world applications tomorrow, including their We Energy STEM Center built to support first teams. Head on over to msoe.edu/visit to see a virtual tour and schedule your campus visit today. Let's start out with your intake on your robot. Talk to me about just some of the design iterations. How did you end up with this design and any testing you did to get there as well?
So first we started with some 3D printed pieces and tubing, and we just kind of shifted everything to get the right center distance on our shaft.
Sure.
And we decided to go with like a 2 shafts to keep rolling resistance down, and we sped it up as much as possible. First we had like a 0.8-to-1 ratio. We kept stalling the motor, so we went to a 1-to-1 on a Neo, and we had a pretty good center distance here, so we were able to use chain and really low rolling resistance. Then we moved to a more simple, less like a lighter prototype with plate, and then we made a final iteration and we added angle and bent pieces to make it stronger. We're using a mini sim to lift it, so we have less stalling with the Neo, and we don't have any pneumatics to keep the robot light.
You said when you started out you did some 3D printing for that. Did you do like a 1-to-1 scale, or like what scale did you create 3D prints at?
So we used 3D printed blocks so we could use tubing and slide the shafts on, and actually do real like tests with it. And we had a set of bumpers on the ground. They were a little worn out because they were 3 years old, but they worked pretty good and got us here. So
that's really cool. When you looked at it from a design perspective, you'll have a little bit more of a rigid intake that we've seen. When you're looking at testing and stuff, why was this the best route for your team to go with?
Well, in the past we've had trouble with polycarb intakes because they just kind of wiggle and shift and bearings popped out. We were really having trouble with that, so this year we decided to go with all aluminum. It's 5000 series aluminum, so you can just bend it back. It doesn't shear like 6061.
Going into more of your indexing system here, a lot of mechanism wheels and different sets that it goes through. Talk to me about as we kind of follow that cargo path through what's going in the inside of your robot there.
Yeah, so slowly we wanted to get the widest possible track width on our intake so we could pick up like a wide range of area, and then we slowly start to funnel it in. We originally just had this shaft, but we had a problem with the balls sticking in the middle, so we added this little plate here, and that has a 2-inch, they're 3/8 bore on a 1/2-inch hex so they don't spin at all. And then that funnels it into the Mechnum drive. This is a pretty unique thing for most robots.
Yeah.
We tested it out with some plywood and 2x4s, and we thought it worked great, so we just decided to send it, and we built it on the robot, and it works very reliably.
Yeah, it just seems, you can see that centering process as it goes through. I really like that a lot, and just seems to be very effective for your team. That's great, man. So let's talk about, let's go into your shooter as the cargo's gone into that. So talk to me about just what's gone into your shooter, the concept for it. I'd love to hear in regards to, from a packaging perspective, it just seems so fluent between the handoff on the indexing system to your shooter as well. So how's that worked out for you so far?
Yeah, so coming off of our conveyor, we call it our vertical conveyor, which brings it to the shooter. And this uses 2 belts on either side that basically compress the ball into this Lexan plate back here. And what that does is it spins the ball around that center point right here, this turning point.
Sure.
And then it feeds into our compliance wheels, which is our indexing system into our shooter. And going on to our shooter, we have 2 sets of 3 6-inch high grip wheels, and we started off with these prototyping, and they ran pretty well, so we never really changed off of them.
What's kind of the sweet spot for GalacTech to shoot on the field?
We like to shoot on the edge of the tarmac.
Yeah.
It's just farther away, our our shooting is less accurate, and closer up, our angle is too steep, and it just hits the bottom of the hub.
And that seems to be a pretty popular spot for a lot of teams to hit as well, too, and obviously working out well for your team so far as well. So let's talk about some of the programming that's gone into your ball pathing as well, too, Rishi. I'd love to hear about any specific sensors you're using and anything else that's gone into it as well.
So starting over here at the intake, since we went with the motorized intake and not pneumatic, we had to find a way to deploy and retract it quickly, especially since it's outside our frame perimeter. So we added an encoder right here, and we've basically cranked that up to the point where we can retract and play very fast. So I'll demonstrate real quick. So after there, the ball goes into our indexer, and at the back we have a Rev 2-meter distance sensor.
Sure.
Moving back here. So that's at the bottom of the shooter, which is the end of the indexer. So the first ball will stop right here, and we can see that in our code, which tells us our ball state. So right now it says we have one ball in the indexer. And after that, we move up to the shooter. And there's a second sensor here. This one's a color sensor. So this sensor will not only stop the ball in the shooter, but it'll also tell us if we have the wrong alliance color. And at that point, we would shoot it at a lower speed to miss the high hub.
Have you done anything like that in autonomous before, where you might pick up the wrong color and it shoots out during auto as well?
Yeah, so we have an auton path that will shoot our preloaded ball and one more ball, and then shoot the enemy ball into our hangar, so
Sure.
It's harder for the opponents to reach.
Love it so far, and cool to hear about that whole process, both on the mechanical and the programming side as well. Let's start to wrap up, talk about your climber a bit more and what's gone into that, and then we're going to show off your climber sequence and how that goes about as well.
All right, so our climber consists of 2 Thrifty Bot climbers, which are kind of in, an Andy Mark style spool setup. So
Sure.
From the spool, it runs down across 2 rollers, which redirects the rope to go vertical into these Thrifty Bot climbers, which work by these constant tension springs pushing the tubing out. So this spool basically just pulls the climber down. And we have a dead shaft that they rotate on with 2 Neos with a 48-to-1 or 1 Neo on each side with a 48-to-1 transmission on each of them to rotate each climber.
Perfect. Let's see that deploy, and if we can kind of just walk through each stage of that sequence as well, it'd be great.
Okay. So here, this one goes onto the mid bar. So you bring it forward, hooks onto the mid bar, pull that one back, pull yourself up. Once you do that, you extend that one. That goes onto the high bar, forward. Well, it'd stop around there.
Yeah,
but,
sure.
And then you pull yourself onto the high bar and release yourself from this one. That one goes back and repeats the same process.
What's kind of the timing on the field for you to do a full traversal climb?
We leave it 30 seconds. I practice quite a bit and during the regular season, but I'm a little rusty now, so we leave.
No excuses here at IRI,
around
man.
35. So.
All right. Well, we'll see if you get that optimized a little bit more as
Yeah.
well, too, here at IRI. GalacTech, really appreciate you taking the time. Tell us more about your team and your robot. Congratulations on Indiana State champions as well, too. So you look for big things in future years, and good luck here at IRI. Thanks a lot.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Discover MSOE, where hands-on learning today can lead to real-world applications tomorrow, including their We Energy STEM Center built to support first teams. Head on over to msoe.edu/visit to see a virtual tour and schedule your campus visit today. If you are a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter. And First Updates Now on Facebook, Instagram, TikTok, and Twitter.